So we've learned about our first ingredient training. Now let's talk about context. If you ran that experiment I asked you to run with autocomplete, you can see that what it's keeping track of are the last couple words that you're saying. If you take out your phone and just keep selecting the next word that autocomplete suggests, you're probably got a sentence that's something like this. It's one where each word makes sense if you just put it next to its neighbor, but the whole sentence itself is nonsense. And that's because the only context for autocomplete is a word or two long. It's the words that you're typing in. It doesn't know that it's blathering on because it really can't remember how you started the sentence. For large language models, context is a whole lot more than just paying attention to the last few words. Large language models have an ability called self-attention that lets them pay attention to every single word in a conversation, every word that you've said and every word the model has said. It's in producing the next word, the most likely continuation of the sentence, just like in autocomplete, that self-attention goes to work in LLMs. They weigh every word in the conversation, treating some as far more relevant than others to decide what comes next. And it uses that conversation to continually update the map that it got from its training. So take, for example, the word bank. In its training data, the word is connected both to financial institutions and to riversides. It shows up next to loan and interest, but also next to river and mud. It's stuck there between two clusters of meaning. Now, for autocomplete, there's no way to resolve that ambiguity, but the attention mechanism does have a way. As the conversation develops, the location of the word bank in the map moves. If you start talking about Wall Street, it moves in one direction. If you start talking about hiking, it drifts in the other. Every single word in the conversation is reweighting the significance of every other single word in the conversation. Constantly, every time the model produces the next word. This isn't just happening for bank, it's happening across the entire geometry. The whole galaxy of tokens updates with every single advance of the conversation. And that's why, unlike with autocomplete, large language models can produce sentences that don't dissolve into nonsense. It can continue a conversation in a way that makes sense given what's been said in the conversation to that point. The model is constantly navigating a geometry of word meaning that the conversation itself continually shapes. You've got two ingredients here: a map of meaning that's built from almost everything we've ever written, and a mechanism that lets the words of a conversation move it.